this is Mrs. Ward, and I am going to go over the worksheet for sections 8.1, which is taking the derivatives and integrals of exponential functions, and 8.2, which is taking the derivatives of log functions. So let's just get started. So the first one is asking me to find the derivative. So I am going to find the derivative using that formula, which says when I take the derivative of e raised to n power, which is going to be e raised to n power, and then I take the derivative of that power, which is going to be 3x squared, and then I'm just going to clean that up by bringing that negative 3x squared up to the front, so it's going to be negative x, and that's it. That's all I can do. The next one is I'm taking the derivative of this. So what I'm going to do is I am going to use the quotient rule. So that means when I take the derivative, I leave the denominator alone, take the derivative of the numerator, which would be 2x, and subtract, leave the numerator alone, and multiply it by the derivative of the denominator, which is the derivative of e to the x would be e to the x times the derivative of that x, which is just 1. Don't really break it, but I've already shown you what I'm doing. X and square it. So when I rewrite that, I'm going to have 2x times e to the x minus x squared times e to the x all over e, and then when I square that, that's 2x. And I'm going to factor out an e to the x in the numerator, and then I'll have, natural factor out x too. So let's do that. So make this 2 minus x all over e to the 2x. And then I can simplify e to the x, e to the 2x. And when I do that, the derivative will be x times 2 minus x, and then this goes to e to the x. And that's as simplified as I can make it. And moving on to the next one, I am doing the quotient rule again. So I am going to leave the denominator alone, take the derivative of the numerator, which is e to the x times the derivative of that x, which is just 1, minus, I am going to leave that numerator alone and take the derivative of the denominator. The derivative of 1 is 0. I'm just going to write it so you can see what's going on. Plus e to the x, derivative of e to the x is e to the x times 1. All over that 1 plus e to the x squared. So when I do that, I can back out e to the x, and that's going to be left with 1 plus e to the x minus e to the x all over 1 plus e to the x squared. And so these two will equal 0. From my numerator, I will have e to the x is 1 plus e to the x over 1 plus e to the x, and that whole line squared. Moving on to the next one. I have natural log, so I have this quotient. I really don't want to do the quotient rule. This one I had to do the quotient rule. This one's going to take the natural log. I can use the properties of the log. So I'm going to rewrite this as x, the natural log of x, plus the natural log of x minus 1, minus the natural log of x minus 2. And then I'm going to take the derivative term by term. Much, much easier. When I do that, the derivative of natural log of x is going to be 1 over x, which is just 1 over x, plus 1 over x minus 1 multiplied by the derivative of x minus 1, which is just 0, minus 1 over x minus 2 multiplied by the derivative of that, which is just 1 as well. So then my final answer is 1 over x plus 1 over x minus 1 minus 1 over x minus 2. And I can leave it like that, or I can decide to combine it with one denominator, but I'm going to do that. I'm going to leave it like that. The next one, I am taking the derivative of the natural log of x, the square root. So I'm going to think of that as the natural log of x is 1/2 power. So I'm going to rewrite that as 1/2 times the natural log of x using the property 9, I'm taking the natural log, separating it, so G, I'm going to rewrite G back as 3 times the natural log of x over 2. Still rewriting it, it's going to be 3 times the natural log of x minus this 2 times this and the natural log of 2. So I might want to rewrite it as 3 natural log of x minus 3 natural log of 2. Now when I go and take the derivative, I'm going to have this 3 here, the derivative of natural log of x, 1 over x times the derivative of x, 1, minus 3, and then 1 over 2, and then times the derivative of 2, which is 0, so that whole term is 0, and so my final answer is going to be 3 over x. Moving on to the next one, I have 5 raised to the x minus 1 power, so I'm taking the derivative of something raised to the power. Remember, to do that, I take the natural log of the base, multiply it by itself, so that 5 times the x minus 1, and then multiply it by the derivative of that x minus 1, which is just 1. So my final answer, I'm going to leave as natural log of 5 times 5 x minus 1. Just make sure I can tell what's the natural logs being taken out and what's not part of that natural log. The next one I had I'm taking the derivative of log base 7. So to take the derivative of a different base, I am going to do 1 over the natural log of that base times 1 over the function, which is 1 minus x, and then we multiply it by the derivative of that, which would just be negative 1. And when I simplify that or combine it, I'm going to have negative 1 over, and then I'm going to write 1 minus x and the natural log of 7. Doesn't matter where you write it in, just as long as I know that you won't take the natural log of 7. Number 9 asks us to find another extreme point. So what I'm going to do is find my first derivative. So when I find my first derivative, I have to use 5 first to remove the x alone. Take the derivative that means the x, which would be e, and negative x, times the derivative of that negative x, which is negative 1. And then I have plus taking the derivative of x, which is 1, and then e to the negative x, and that alone. Then what I decided to do is I decided to factor out that e to the negative x. When I did that, I was left with negative x plus 1. So that's my first derivative. Find my critical numbers. When I actually wrote negative x plus 1, it would be plus. Find my critical numbers. I take my first derivative and I set that equal to 0. The only way this is going to be 0 is when that numerator is equal to 0. And when I do that, x is equal to 1. So my one critical number is x is equal to 1. Next one is I'm going to find, the next time you find a critical number is when the first derivative is undefined, which means that e to the x equals 0, and that never happens. So that's not going to be a critical number. So then I'm going to do my table. I'm going to pick 1. I'm going to pick test points. So let's say I pick negative 1, and let's say I pick, well, I probably pick 0, to be honest. And then let's say I pick 2. Then I'm going to go back and do the first derivative. So I'm going to find the first derivative at those points. So when I put 0 into this, my first derivative, that's going to end up giving me a positive number. And when I put 2 in here, that's going to end up giving me a negative number. So my function is increasing, gets this relative maximum and then it starts decreasing, so this is going to be relative max. And so I know I have a relative max. And that's going to happen at the ordered pair of 1 and then after 1. So I'm going to go back up and put 1 into the original equation. And when I do that, so f of 1 would be 1 times e to the negative 1, and that would be my original equation. And when I do that, I get 0.3679. So that is my relative max. That's my relative max. If I want for a pair, I would write 0.3679. I'm going to use a quotient rule, so I'm going to use e of x alone. Take the derivative at negative x plus 1, which is negative 1, minus e at negative x plus 1 alone. Take the derivative of e to x, which is e to the x, times the derivative of x, which is 1, all over e to x squared. So when I do this, I'm going to have negative e to the x plus x times e to the x minus e to the x, all over e to the 2x. So when I'm combining, I'm going to have negative 2 e to the x plus x times e to the x, all over e to the 2x. Factor out e to the x in the numerator, and so we end up with negative 2 plus x all over e to the 2x. This can simplify. Negative 2 plus x all over e to the x. Now when I go to find my inflection points, I need to set up that chart, and I need to find my critical numbers before I can set up that chart. So my critical numbers, and actually those are my paper critical numbers, is when I set the second derivative equal to 0, that negative 2 plus x equals 0. So x is going to equal 2. And then when is this second derivative undefined, and that's when the denominator is 0, which does not happen. So now I know that I might have inflection points. Remember, you have to change quantitating up to quantitating down to find inflection points. So I'm starting with 2, and let's say I pick a number to the left, and I pick 0, pick a number to the right, I pick 4. So when I put in my second derivative, so when I put in 0 in here to my second derivative, I end up getting a negative number. And when I put 4 in there, I end up getting a positive number. So I'm quantitating down, then quantitating up, which means I knew that I have an inflection point at 2, so it's going to be 2, and then it's equal to, which means I'm going back to the original function, way back here, and I'm finding 2 for that. And when I found 2 for that, found 2, that ended up being 0.2707. So my inflection point has to be right here. 0.2707, and that is my inflection point. Okay, moving on to the next one. I want to find or evaluate the integral. So I am going to, since I have e raised to the x to the third, I'm going to substitute my d to the x to the third. So the derivative of u would be 3x squared dx. And remember, this is where I did the highlighting thing. So I have the x squared dx, I need to get that 3 out of the way, so this is 1/3 du is equal to x squared dx. Now when I go and rewrite this, I can rewrite e to the u, and then the 1/3 du to take care of that x squared dx. This is plus, doesn't matter. Okay, so then when I go to do this, the derivative of e to the u is just e to the u, so this is 1/3 e to the u plus c. So now I'm going to substitute back in, so I'm going to have e to the x to the third plus 1 plus c, and I'll put this all over 3, and that's going to equal my f of x. So this, when I go to do this, I am going to have to use that e substitution. I'm going to rewrite this as e to x and e to x minus 1 to 3x power dx. And then whatever I'm raising to the power, that's what I'm going to do for my u substitution. So that's going to be e to the x minus 1. The derivative of that is going to be derivative of e to x is e to the x times the derivative of x, which is 1, derivative of this minus 1 is 0, and then dx. And I have that up here. I have this dx dx, so 3x negative 2, and then plus c. So then I am going to rewrite this as x equal to negative 2 over my u, which is that e to the x minus 1. And it's the 1 half power plus c. And I believe this is it. Okay, moving on to the next one. I'm going to do substitution again. Whatever I'm raising to the power, and yet no expert to raise to the power, but I am going to focus on that e. And so when I raise that, I'm going to say u is equal to 3x. So I'm going to think of u as equal to 3 times x equals 1. So when I take the derivative of that, it's going to be negative 3x to negative 2 dx. So just to be clear, that's negative 3 over x squared dx. I have that x squared in the denominator dx. So that's in that. I have to get this turned out of the way, so I'm going to write negative 1/3 du is equal to 1 over x squared dx. So when I write this, I can write this from 1 to 3 of e to the u and then du. And this is with x is equal to 1, x is equal to the number since I switched everything in terms of u, I have to make sure that I identify that 1 and 3 as being the x values. Then once I do that, I can take the antiderivative, and the antiderivative is going to be negative 1/3 e to the u with x is equal to 1, x is equal to 3, since I'm doing the definite interval. So now I'm going to substitute just do it. So then negative 1/3 e to the 3 over x minus, oh no, so what we're going to do is, this is x is equal to 1, x is equal to 3. So now substituting it, we have negative 1/3 e to the first minus 1/3, negative 1/3 e to the third. Let's say I have a 1 and 3. When I do that, I calculate 5.787. Okay, moving on to the next one. I am doing u is equal to negative x squared. The derivative of u is negative 2x dx. So going up here, I have x dx, I have x dx, and delete that 2 out of the way, so I'm going to negative 1/2 to u equals x dx. So when I write this, this will be u e to the u, and then du will be negative 1/2 du. So when I take the indefinite interval, I'm going to have negative 1/2. Take the interval of u to u, that would be e to the u, and that plus c. So then f of x is equal to e to negative x squared over negative 1/2 plus c. And I think I'm going to do that. The next one, find the area of the weakened bound by the graph of the equation. So I graphed on the calculator. You have to know, not really, but I did. So I have this graph that looks like this. And I'm going from x is equal to 0 to x is equal to 2. And here's the shape of the region that I'm finding. Basically, I'm doing a definite interval of 2 e to the negative x from 0 to 2. So when I do that, since I'm raising this to something other than just x, I'm going to say u is equal to negative x. So the derivative will be negative 1 dx. So I'm going to have to make sure that this negative 1, I have the dx, I'm just going to have the negative 1, so negative 1 du is equal to dx. So B, still x equal 2 of negative 2 u v. So the integral of b to the v is just going to be e to the v. So there's like an integration of 0 to 2. Putting substituting back in, and then negative 2e and negative x. And then I don't have to write x is equal to, I can multiply that in terms of x. So when I do that, I'm going to have 0 to 2. So substituting in, negative 2e, negative 2 minus negative 2e to the 0. Well, this would be negative 2. And then this is what we're going to do. When I do that, that ends up being 0.2727. So my answer is 1.72. And that's my final answer, and I think